why math wouldn't make sense if when we have, for example, a is less than b, and then multiply both sides or divide both sides by a negative number. So if we do like negative a, it wouldn't make sense to have this. Negative a is less than negative b. So I'm going to show why it wouldn't make sense to have a is less than b and negative a is less than negative b, or anything of the sort. A is greater than b, negative a is greater than negative b. So first off, we have the number line. So you have 0 right there, extends to left and right infinitely. We have 1, 2, 3, negative 1, negative 2, negative 3. And then we just have dot, dot, dot on both sides. And then, so what I'm going to do is I'm going to just draw an arrow here. I'm going to sort of transform it. So here we have 0, 1, 2, 3. We have a dot. And then we have, actually, it does not extend infinitely to the left, but it does extend infinitely to the right. So here we have negative 0.0 dot 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 1. So basically the smallest negative n, where n is, the smallest possible even number, or positive number. Here I'm just going to write POS dot. So we might as well just say negative epsilon. Anyway, here we have negative 1, here we have negative 2, and here we have negative 3. But then here I'm going to draw an infinitude of points on this number line, right? This might seem sort of like counterintuitive. This is just a thought I was having. Because, sometimes I get annoyed that, like, when you multiply or divide both sides of an inequality by a negative number, you're going to have to remember to change the, flip the sign. So here we have an infinitude, infinity, and then in here we have negative infinity. So in this case we have we have negative epsilon is basically the smallest negative number, and then we have negative infinity is actually the biggest negative number, not the smallest. So this is like the opposite. And so yeah, just take a look at this. This is just an idea I had yesterday. So I'm sure most of you are familiar with, if a is less than b, example 3 is less than 5, we have negative a is greater than negative b. Example, negative 3 is greater than negative 5, and then you can extend this to all types of inequalities. A is greater than b. Example, 7 is greater than 4. Then negative a is less than negative b. Example, negative 7 is less than negative 4, right? If a is less than or equal to b, example 1 is less than or equal to 2, we have negative a is greater than or equal to negative b, right? Multiplying both sides by a negative number. Example, negative 1 is greater than or equal to negative 2. And finally we have if a is greater than or equal to b, example, 8 is greater than or equal to 8. Negative a is less than or equal to negative b. Example, negative 8 is less than or equal to negative 8. So basically these are the rules. And here's a nice diagram for it. We have 0, and then we have, I could think of it this way, a and b. This is just sort of a visual as to why we need to flip the inequality sign. Negative a is negative b, so we have like negative b is less than negative a. But at the same time, we also have a is less than b, right? We can write this as negative a is greater than negative b. So there you go, we multiply both sides by negative 1. You have to flip the inequality sign. That's just a short little proof by example. And another thing I got is that, so if you remember the second number line I made, the just sort of like theoretical number line, we have a set of rules. We have basically the same thing, except we don't flip the inequality sign each time. So if a is less than b, example, I'm going to do the same examples. 3 is less than 5. But what's different is this part. Negative a is less than negative b. So in this case, negative 3 is actually less than negative 5. So negative 5 is greater. And if a is greater than b, example, 7 is greater than 4, negative a is still greater than negative b. So in this case, we don't have to flip the inequality sign. So example, negative 7 is greater than negative 4. If we have a is less than or equal to b, example, 1 is less than or equal to 2, it stays the same. Negative a is less than or equal to negative b. Example, negative 1 is less than or equal to negative 2. And finally, if a is greater than or equal to b, example, 8 is greater than or equal to 8, we have negative a is greater than or equal to negative b. Example, negative 8 is greater than or equal to negative 8. And then, yeah, so these are all the rules for this theoretical number line. And yeah, so I hope you like watching this video. This was just sort of like a video about why math wouldn't really work if we didn't have to flip the inequality sign each time we divide or multiply by a negative number. And yeah, see you in the next video.